Sorry, is it fixed now?
Yeah. It's fixed now, so
Okay.
we can start.
Okay,
It's
so it
fixed, so
sounds.
we can start now.
Yeah, okay.
All right. Yeah.
Okay. So today's topic is on matter and their different properties. So today we'll learn about what matter is and what different properties they can have. So we'll start with some vocabulary before we go on to some videos that we can watch. So matter is anything that has mass and volume. What I mean by mass is the measure of how much stuff is in something. So, for example, this might have more mass than this on the left because it has more stuff in it. And volume is the amount of space something takes up. So, matter is anything that has stuff in it and takes up space. So, it can be anything that you can see or feel. Those are all matter. So, the gases, the solids, the liquids, all of the things that you can see and feel are composed of matter, since, of course, they are stuffed in with something and they do take up space. There's one law according to matter, and it's the law of conservation of matter. We will learn about that today. What it means is that it tells us that the amount of matter stays the same even when a substance changes form. So, if a solid turns into something else, like liquid or gas, the law of conservation of matter states that the amount of matter stays the same. Even after it goes through the change, or even after it looks like it disappeared, it never did. And it's still there. But it just changed forms. Again, for example, like from liquid to gas. You cannot see gas, but you know that the liquid changed into the gas form. So it states that the amount of matter stays the same. Now we'll also learn about some different properties of matter. So here is a list of few. So we'll learn about density, magnetism, solubility, and conductivity. Density, which we'll learn, is it measures how close together the particles are inside a substance. So, to explain it with the terms that we learned above, if there is a fixed volume, for example, there is a fixed volume for these two substances right here, but what determines density is how much more particles are inside that fixed volume. So you can see these are both cubes, but density depends on how much stuff is in it. So you can see the one on the bottom has more particles in it. It means that the bottom one is more dense than the one at the top, because there is more particles in a fixed volume. And we will talk more about the density and how we can use that to test some of the properties of matter in just a little bit. The next one, magnetism. It's pretty simple. It's the force that pulls or pushes certain objects to magnets. So this we will see can distinguish some metals. And the next property is solubility. And this measures how well one thing can dissolve in another. Some things can dissolve in one substance, but the other may not, so we can distinguish these types of properties. And the last one, the conductivity, it's also pretty simple. It measures how well something can allow electricity to flow through it. So if there is an object in between and we pass through some electricity, if electricity can go directly through the object, then it conducts electricity, and if it doesn't, it does not. So it depends on if the electricity flows through the object or not. We will learn more about these in the video coming up, and I will do a recap of that as well, so don't worry about it too much if you don't understand it yet. We'll get to it in just a bit. So let's watch these two videos that I prepared. It's a really fun video which tests a lot of experiments. And yeah, the first one is about the law of conservation of matter. So that was the first video, and it was about the law of conservation of matter. We quickly learned about that, and we will actually watch a second video. It's also about 10 minutes, but this will focus more about the properties of matter specifically. So what kind of properties they have, and how can we test them to see the difference. That was the video about the properties of matter. And let's go ahead and take on some of the concepts that were shown in the video. So the first and the most important concept that we introduced with was matter. And matter is anything that has mass and volume, like we talked about. The video talked about having weight and takes up space, but relative to Earth, it is the same definition, but it's more formal to use mass and volume. So we talked about mass. On the right, you can see being the amount of particles in the volume, so the amount of stuff that is inside. So mass, you can see both of these have mass in it, so we call all the stuff inside a volume a mass, and the volume is the space that it takes up. So when things have stuff in it and it takes up space, then anything that follows from that is called matter. And matter has three forms, like you guys know: solids, liquids, and gas. And it can easily change from one form to another. So like the ice can be heated to be turned into water. And many other form changes exist. This introduced us to the law of conservation of matter. So the law of conservation of matter says that the amount of matter stays the same even when matter changes forms. So although things look like it disappeared, nothing can just magically appear or disappear. So in this bottom example, you can see the fire and the wood, and we start with the wood on fire, and then we end with a pile of ash. So even though the substance look different, for example, the wood isn't this log-shaped wood anymore, and the fire isn't there, it's just left with a pile of ash. But ultimately, the law of conservation of matter states that the amount of matter that is inside the ash and inside this log are the same. It might not exactly be the same because you can see the carbon dioxide and water vapor leaving from the substance as the wood burns, but the law states that it's approximately the same. Same amount of matter that is in the start of the logs and at the end in the ashes. Another example is regarding the form change, maybe a more simpler one, like water to gas. So although it looks like the water just disappeared and vanished, it simply just changed into water vapor, which we can't see really well with our naked eye. So you can see the water boiling, turning into water vapor, and yeah, those gas forms are less visible, and it looks like it disappeared, but it's still there in the air. So that was the law of conservation of matter. The amount of matter staying same, changing forms. Yeah, you don't need to copy all of it down. Like examples, I'm just telling the examples to make it a little bit more clear. But another thing to remember is that when a new substance is made, it is created from existing matter. So again, this is similar to the concept of law of conservation of matter, that nothing is created from what wasn't before. So everything, when it goes through a change, has to come from the matter that existed before. So no new matter is created nor disappeared. Okay. And now, moving on to the properties of matter, this gets into the second video that we watched. And matters have unique properties that we can describe through properties like magnetism, density, solubility, conductivity, and more. And there are a lot of different properties of matter that we didn't get to today. We will only talk about 3 properties, which are magnetism, density, and solubility. But you can see on the bottom chart, and there are even more than this, that things like texture, colors, volume, length, melting point, boiling point, like shapes, temperature, elasticity, and there are many more properties of matter that we didn't discuss today, but know that they exist, and we can distinguish matters by their different properties. So first, let's start with magnetism. It's the first property that we saw in the video. And magnetism is the ability of a material to be attracted by a magnet. So this helps us distinguish metals such as iron, cobalt, nickel, and etc. So magnetism helps us see which one is metal and which one is not. So we will see if this has metallic properties. And on the left, this is the magnetic force that it exerts when we put two magnets together, the N meaning the north side and S meaning the south side. They attract each other, you can see, and the other ends repel each other. So the magnetic force is the attraction and repulsion. And on the right, you can see that the magnet is only pulling the red spheres. And you can see that those are the magnetic ones and not the clear ones. Next, we will talk about density. And density depends on how closely the tiny particles are packed together. So objects with a high density have particles that are more tightly packed than objects with a low density. Things float or sink because it is less or more dense than the other. Okay, so density is, you can see on this bottom picture, this one describes well what density is. So you can see that there is a fixed volume. Both of these cubes are the same size. It takes up the same space. But you can clearly see that the right one has more particles in it. You can see it's closely packed together. Unlike the left one, which the particles are spread apart. You can say that the one on the right is more dense than the one on the left, because it has more particles tightly packed together in the fixed volume. And you can see on the one on the right, this determines the density relative to the water. This is testing against water. So water has a certain density. It actually has density of 1. And we're testing different matter if it floats or sinks. So when it floats on water, then, let me type it. If it floats than water, it's less dense than water. So you can see both the first and the second one is less dense than water, because you can see that it floats on water. Only the substances that are less dense than another substance floats on it. But you can see on the right, this cube sinks in water. This suggests that this material is more dense than water. These are small tests that you can conduct to test the density of things. And density is really important when distinguishing substances, because each substance has different density. And you can test against not just water, maybe something else, some other liquid, to a solid, and see if that solid sinks in the liquid or not. Again, you can just remember as floating less dense, the object is less dense. Sinking, the object that it sinks is more dense than water but you can use other liquids as well. So that was about density. So one more thing, because it is the amount of mass per volume, we measure it by grams per liter, milliliters, or kilograms per liter. Those are the same units. So okay, this is the unit of density. So for example, this might have 0.5 grams per milliliters. So this object might have 0.5 grams per milliliter, but the density of water is 1 grams per milliliter. So which one is more dense? Of course, the water is more dense. It has a higher density. And this cube has 0.5 grams per milliliter. So then it floats. And if for this one, you can say that this has 2 grams per milliliter, but the water has only 1. So you can tell that this one floats and this one sinks. Okay, that was about density. And now let's move on to solubility. So solubility describes how well a substance can be dissolved. So some substance can be easily dissolved by water or other liquid, and others may not. So, for example, in the video, it talked about salt is soluble, but acetone isn't. So you can see the diagram on the left. If it has precipitate, what is left over? This, let me quickly make a distinction of solute and solvent, because I don't think we've talked about it yet. Solvent is the liquid, but the particles that we put in, let's say we have a bowl of a certain substance. This is the thing that we want to put in the liquid, and these are called solutes. So these are different distinctions I want to make. Things we put in the liquid are called solutes, and the liquid itself is solvent. And then if we put the solute in the solvent, if the solute sinks down and forms this precipitate, the solute at the bottom of the solvent, then it is not soluble. So this is this solute is not soluble because you can see it did not dissolve in the liquid, in the solvent. But this one, on the other hand, on the left, this one, you can see that the particles are all dissolved in the solvent. The solute is completely dissolved in the solvent. So we can say that another solute is put in the solvent, but it all dissolved. So we say that this solute is soluble. in this solvent. So we can test solubility like this by pouring a certain solute to maybe the same solvent to see which one dissolves or not, to tell the difference of certain matter. Again, solubility is one property that we can test. And yeah, those were the 3 properties that we talked about. But as I have said before, those are not the only 3 properties of matter. There are many, many more properties that scientists and engineers need to test to identify what it is. Because we can't just identify with only 3 properties. We need to have way more than that. So you might be asking, why are properties important? Why are properties of matter important? So, especially for engineers, I heard that some of you guys want to be an engineer when you grow up. They need to know well of many different properties of matter to use appropriate materials. So engineers need to distinguish which matter is which, and which matter is better, for example, conducting heat, conducting electricity. They need to know all these properties of matter. So for example, this is a quite long example, but if you are making a rocket engine on the right, if you're trying to make a rocket engine, it might seem like a good idea to make it out of, for example, aluminum metal. Let's call this aluminum metal. So it might be good to make it out of aluminum because it is a light metal. So this metal is very light. So it seems like it would be a good material for the rocket engine, because what does a rocket need to do? It needs to fly to space, right? So this is the rocket, and this is the rocket engine. So people might say that we might add aluminum to make the rocket engine. Maybe this part, this whole thing, this rocket engine on the right. But there's a problem. Aluminum would also melt from the rocket's heat because it's not that heat resistant. It can easily melt from the fire that it comes out. When the rocket boosts itself to lift off, the heat melts the aluminum, so it would not be a good idea to make it out of aluminum. In this case, here, you might want to choose ceramic, for example, which is the same thing as pottery is made of, and because it has better properties, it withstands heat, and it's also relatively lighter than other materials. So by testing these different properties, does it withstand heat or not? Is it light or not? Is it maybe dense? And does it conduct heat? Does it conduct electricity? Especially engineers need to know these differences in order to make their new product. So you can see the importance in properties of matter. You would need to know how to test them and how to tell the difference between matter. Yeah, I hope that was all clear. So if everyone got it down, I'll move on to the next one. So we will quickly have a review quiz, like a certain questions, um, so we can answer a couple of them. So let's see this one. This first question. So according to the law of conservation of matter, if you dissolve 25 grams of sugar into 150 grams of water, the mixture should weigh how much? Oh yes, I think I heard the answer. Yes, that would be right. It will be 175 grams because it's pretty straightforward. 25 grams of sugar and 150 grams of water. If you mix them, nothing is created nor destroyed, so it should still weigh 175. Okay, the next question. Do you guys remember the fire snake? It was the one where he put, I believe, sugar and baking soda onto the sand pile, and it made this huge snake. Remember? It's like a snake shaped reaction with the blown up sugar and baking soda. So in this experiment, why was the weight of this fire snake slightly less after it was lit on fire? Does anyone remember that? Yeah, so what I'm drawing here, it's like gas particles. So the weight of the fire snake was slightly less than the total weight of sugar and baking soda because some of it was released into the air. So some of them turned into gas and went into the air. So of course that would make the weight of the fire snake a little bit less than the original sugar and baking soda combined. So the answer to this is that some converted to gas. So some of the substances did convert to gas. And we will skip through some of these because it is pretty easy. I have this one more problem set. Maybe there are more better problems here. This is about properties of matter. So okay. So this first question, why does a balloon filled with air weigh more than an empty balloon? Maybe can anyone use the terms that we learned today to answer? So remember how in the video, um, the balloon filled with air weighed more than the empty balloon, because I heard maybe some of you were trying to say that this has more weight in it. This balloon with the air has more weight because air is matter. So the balloon with air has more matter in it. And if it has more matter, then it weighs more because it has more mass. So that is why the balloon with the air weighs more than the empty balloon because it has more matter. This is like maybe like the last two questions. It's pretty straightforward. Maybe some of you like to answer this question right here. So what is it called when something dissolves into something else? Is it liquidity, density, viscosity, or solubility? When something dissolves into other. Yes, I think I heard solubility, and that is right. When something dissolves into something else, it's called solubility. And when it does dissolve, it's soluble, and when it does not dissolve, it is not soluble. Those are the tests that you can see. And yeah, I think that is all the questions that I had for you. Let's actually do this one last question. So, what property did the team use to tell the two gases apart? Remember, the team had two types of gases. So we had two containers of gases. One gas was helium gas. And the other one was sulfur hexafluoride. These were the two different gases that we had, but we couldn't tell the difference because on the outside they both looked like gas. So what did the team do? They attached the tube to a balloon. They inflated balloons with it. It's the same size, but this one is filled with sulfur hexafluoride and this one is filled with helium. So, do you know what test they did? What property they used to distinguish between these gases? Does anyone want to try this question? Oh yes, I heard density, and that is correct. Yeah, great job on that. Because we have air in the atmosphere. We have a lot of air in the atmosphere. So like we have air particles in the air, but air is basically like a mix of certain gases, but it also has oxygen in it, some nitrogen, and other gases. But if we have helium balloon and sulfur hexafluoride balloon, sulfur hexafluoride is more dense than air. So what will happen if it's more dense? It will sink. Helium, on the other hand, is less dense than air. So what will happen to the balloon that is less dense? It will float. We discussed how more dense will sink, less dense will float. So they tested it, and one of the balloons floated, makes it helium, and the other balloon sank down in the air, makes it sulfur hexafluoride. So yeah. Those were the different gases and density. So I think we reviewed all of them, all the different properties in the test. I hope it made sense for most of you. So yeah, thank you. And do you have any other questions that you would like to ask me for today? Yeah, do you have any questions about maybe some of the concepts, or maybe regarding some of the questions? Um, yeah, feel free to ask me. Oh, sorry, can you come up and say it? Because I cannot hear you very well.
Yes. Yes.
I can't hear you very well. Um, maybe can you type out your question? Yeah, I think it's okay, disconnected, but yeah. Um, did you have a question? Because I can't hear you very
What's the
well.
meaning of this?
What is
This
the
was the
meaning
meaning of this.
meaning of what again? Sorry, can you repeat that?
Yes. F F
Yes, I can't hear you very well. Um,
Yeah, I'm typing the question to you.
okay.
Oh, do this.
Oh, I think you're asking about a part of the video, like a fizzy tablet. I think, are you talking about the one on this video? Let me see. So I think, oh, never mind. I think it's this video. Yeah, I think you're talking about this fizzy tablets. Um, yeah.
Keep quiet. Ah,
So what this person, Zoe, added to the water and the oil mixture, it's a fizzy tablet. So basically, all it does, look at her pouring the fizzy tablets into the oil and into the water. That basically, the fizzy tablets, when it goes in water, makes a certain chemical reaction, and it does produce carbon dioxide gas into the air. So it is used to create carbon dioxide gas as it reacts with the water in the bottom. That's why it creates all the bubbles you can see. Wait a minute. You can see all these bubbles inside the oil. When the fizzy tablets reacts with water, it forms carbon dioxide gas, and then it goes into the oil. You can see all these bubbles, and that is the fizzy tablet reacting with water. You can see all the bubbles. So yeah, I hope that answered your question about the fizzy tablets. Any other questions about today's topic? Yeah, so sorry you guys were
We
disconnected,
had a
but
problem with the network.
okay, we will learn about energy transfer next week.
I think energy transfer for next week.
Yes, that's correct.
You mean energy transfer for next week? All right. All right. Okay,
Yes,
so can you hear him? He said energy transfer for next week. Yeah, transfer of energy from one state to the other. All right.
Yeah, I'll see all of you next week then.
All right.
Okay, yeah.
See you too. See you too.
Yeah, see you too. Bye.